now because of this.
Here we go.
Absolute joys of changing 500 litre this. Alright, good morning. I'm just wondering what happens when this actually runs out.
E01.
Right, so I've arrived at this site and obviously this is down, there's no inverter on here, this don't work. That's the primary side pump, so that's what draws the heat from the boilers. Secondary side doesn't work, so this plate here doesn't do anything. This side, secondary pump's running, so it's pulling water out of the plate. The primary side pump's not.
So Alpha Intec 2 with a E01 fault.
The Alpha Intec 2 is a full combustion controlled condensing boiler. In some documentation you may see them referred to as CCCB, so that's combustion controlled condensing boiler. And the way that works is it uses the ionisation current from the electrode as a reference point to how good the combustion is. We only need 2 hands for this. There we go. And using that ionisation current, the PCB controls how open or closed the gas valve is. So if you have an E01 fault, besides the usual more obvious issues, the fault can actually be a problem with that electrode, a problem with the gas valve, or a problem with the PCB. Now in my experience, this gas valve, as in the GA Baxis and other brands of boiler that have it, the gas valve does seem to be problematic in this country, although it's not problematic throughout the rest of the world, believe it or not. Gas is off underneath. Have a good check over this boiler. Okay, taking the condensed trap out. I'm now going to take the flue collector out. Then I'm going to take the burner and the fan out in one, and then I'm going to check the electrodes, look through the heat exchanger, and if I can find nothing wrong with any of that, I'm going to replace this gas valve. I've already done inlet pressure and that was fine. This is all very monotone and boring. I filmed this in 2019. I was going to do a series on combustion controlled condensing boilers because they were relatively, I want to say relatively new, they were reasonably new. Baxi, I think, sort of kicked it off with a GA. Initially, they were all using that sort of red gas valve, which is a battalion partner gas valve with 4 wires. Now, what them wires did, 2 of them wires opened one solenoid, because the valve's got 2 solenoids, isn't it? So 2 of the wires opened one solenoid. We'll call that the safety solenoid. That's the first solenoid, okay? And the other 2 wires used pulse width modulation signal to try and balance the second valve in a state of open or closed, okay? So it was never fully open, it was never fully closed. That was the one the boiler was varying to control the combustion. So that was Battalion Partner's way of doing it. And then Honeywell with Vaillant came out with the other way, the in my opinion, more robust way, okay? And they done the same thing. They used ionisation current to the PCB. The PCB then worked out what to do with a stepper motor. So then on the Ecotec 2, which is what I call it, which is the Ecotec from 2012 that had the sideways on gas valve with the yellow plugs on it. The yellow plugs go onto a stepper motor, and that is actually the PCB is able to fine tune how much gas is letting through based upon the ionisation current. I'll also say that Ecotec 2 used a MAF sensor. So above the gas valve there you have this little white thing, and that's a MAF sensor. So basically a MAF sensor is used to measure air, how much volume of air is going through something. Coil is heated and 2 temperature sensors take readings. It knows how much air is flowing through a certain part of a boiler or engine. That again, a MAF sensor started on cars. A great way to see this in the field, and I'm telling you now, no one's showing you this. I haven't shown you. I will tell you this. You can do it for yourself. If you're on an Ecotec 2 boiler, you can hear that gas valve going. You can hear it chattering away as it's moving in and out. If you were to have the boiler running, have it running nice and smoothly, and then slowly start closing the gas valve underneath the boiler, the isolation cock, you'll get to a point where you'll hear the boiler trying to adjust because it's getting a low inlet pressure and it's affecting combustion. You'll hear the gas valve start chattering around, adjusting combustion. And if you've got an analyzer in it, you can watch the combustion go out
you'll hear the gas valve chattering and you'll see the combustion come back in line. It's really impressive to see it in the field. Vaillant have then gone one step further with, I think it's called the IQ Green. So the IQ Green actually has a lambda sensor in it, which is an oxygen sensor in the flue. Right, I'm saying this off the cuff. I don't actually know if theirs is a lambda sensor. I'm assuming it is, because that's the technology that's out there. That technology has been in cars since catalytic converter days. So I think catalytic converters in the UK became compulsory on H or J reg cars, something like that. And so when they put a catalytic converter in, they got a lambda sensor, which is what boilers were only getting in 2000. I don't know when the IQ Green came out, what, maybe 5 years ago? Maybe. That's when domestic boilers, as far as I'm aware, started actually using full combustion control. Because once a boiler can measure its own oxygen levels, it can adjust combustion to get that as safe as possible, but also as efficient as possible. I'll give you a little side note here on combustion, just a general rule of combustion, okay? Combustion is combustion, no matter if it's in a car, a boiler, whether it's gas, oil, LPG, petrol, diesel. Combustion is combustion. You need a certain amount of fuel plus a certain amount of air or oxygen to combust. To get the cleanest combustion possible and extract the most heat from it, you need to use the least amount of air possible, because every extra amount of air you put into that combustion process takes heat away with it as it goes out of a flue. Boilers that actually run more efficient are running higher levels of CO2 and lower oxygen levels. That's simply because the higher you get the CO2, the least amount of air you're putting through that combustion process, which means the more energy gets retained by the boiler instead of going out the flue. But in that same breath, if you take combustion to a point where it's super efficient, you're running on a knife edge, because the moment you lose some air going into that, getting entrained into that combustion process, i.e. the fan gets a little bit slower, you get a cobweb in the flue, you get anything like that that can reduce that amount of air, will also then cause the combustion process to fail, and then you'll get really high levels of CO. In the UK, I'm not sure about the rest of the world, we try and balance safety with efficiency, because really we could run all our boilers, higher. Instead of running around the 9 to 9.5 marks, we could push that, but we don't, because we would then take the safety margin away for people like me who don't service their boiler for 11 years. My boiler would have been producing massive levels of CO if, when it was serviced last, it was set with high levels of CO2. So the whole combustion process, all boilers are designed to get that efficiency and safety correct. So the venturis, gas valves, orifices, burners, combustion chambers, flues, all of that is designed with that 9, whatever the manufacturer says, say 9.8% CO2. That's all designed into it when it's made. So unlike a commercial boiler where you've got a shell and you've got a burner stuck on the front, where you can finesse that, you can fiddle with that to get it just right. And if you do the boiler every year, you can start to make that boiler a little bit more efficient knowing the site. Yeah, so you can increase the CO2 percentage to make that boiler run a little bit better, make the boiler be able to extract a bit more heat from the combustion process. But also then you've got to watch your flue gas temperatures, because you don't want things to condense in the flue and rot flues on older things. And it's a fine balance, combustion. And what manufacturers are doing now are trying to get it right. So Vaillant, I can tell you Vaillant's evolution because I know their boilers like the back of my hand. So they went from Ecotech 1, which was you manually set the gas valve. Ecotech 2, it uses a stepper motor on the gas valve with a yellow plug to control the combustion process really finely. And the IQ Green uses a lambda sensor, which is full complete combustion control, closed loop combustion control. The boiler's directly measuring its combustion gases. Now, commercial boilers, I can tell you there's a Hoval Ultra Oil. So that's an oil boiler, also uses a lambda sensor in the flue. And that's oil, and it can fully modulate that boiler. It can control fuel pressure, air pressure, and it's got two, I think it's 2 nozzle, I think it's 2-stage. But so that's real good full combustion control, which is what all manufacturers of boilers are that's what they're gonna end up having to do. If we go hydrogen, realistically, they can make a boiler now that can work on anything. by having that combustion control, and you just set a parameter saying what it's used and the boiler will sort itself out from there. The Batelli and Partner gas valve, I mean, people who have worked on the Baxi GA, you know, that I think that was out in 2004 or so. That was a way back. You know, Baxi were on top of that technology really early on. You'll know they didn't really work very well. And I'll say on the warmer house boilers, until we got the black gas valve, so the one with the black plastic modulating coils, them boilers there, you put a gas valve in it, you put it on auto calibrate. On auto calibrate, what that boiler is doing is it's lighting, looking at the flame using the ionisation current of the electrode, and then it's trying to adjust itself, okay? And then it goes out, and then it does it again. And what the boiler will do is it'll do that on ignition a few times, get that where it thinks it's right. It will then use that to base its high power on. It will ramp up to high power, finesse it itself, try to, then it will do it on low and finesse it itself. And I'll tell you now, my experience, that didn't work. And you would always have to, if you've done that and put a boiler in the self-setup mode, the combustion would be off. That's just my experience. I never found them to be very reliable and set themselves up perfectly. So you'd have to then go in and manually do it. And in the manual range, you'd often run out of range before you got combustion right. Okay, there wasn't enough control, and because the Batelli gas valve is trying to float something, it's using a normal modulating coil that you send power on it to open a valve. It's using that, but it's trying to use PWM, so it's trying to use an on-off signal rapidly at high frequency to control how open or closed that is. So it's trying to open it to a point and then suddenly close it, open it, so the valve floats. I'm pretty sure Wiesmann have something pretty good, but I haven't looked into it. No doubt everyone's down this route now. I haven't really looked into this for at least 3 years, 4 years, but I'm sure all manufacturers will be doing some form of combustion control, which, you know, means that we only have to check combustion. We won't really need to set it anymore unless there's problems. All of this magic trying to control combustion, all of this stuff has been on cars for 30 years, probably longer than that. Boiler manufacturers should really just look at the car industry and use the robust systems to control combustion properly. I mean, we're only trying to control a gas as well. And in every country, you get certain parameters that gas is produced and manufactured to. With car manufacturers, they've got, you know, a car that's in the UK today could be on the west coast of Africa in 2 weeks. The difference in quality of fuel is going to be immense, but that car needs to operate in both countries. So car manufacturers really they've had to pioneer the way forward on this, and the boiler manufacturers need to just catch up. It's that simple. They just need to catch up. I don't know enough about other manufacturers. I know Baxi done it, I know Alpha done it, I know Vaillant done it, I'm pretty sure Wiesmann have done it. I've got a funny feeling Ideal have done it as well with the stepper motor gas valve as well, but I'm not a fay with them because I've been out of the domestic side for quite a while. I'm dipping my toes back in now. But if you know about it or know about who's doing it and how, put it in the comments. I'd really appreciate it, because I'm interested and I don't get out enough to see this stuff in action in the real world anymore. So please let me know. Let's get back to my monotone.
There's the gas pipe off the gas valve. Obviously that went up there like that. That's basically the injector, or the orifice. From here now, we'll take out this. There's the sump, that comes out nice and easy. So now we'll have a look at this. So that's all ready to come off. There we go. There's the fan and the mixing arm and the venturi. There's the burner, which is, it's not hot. Okay, so here's the burner. Have a good look through there. Looks okay. Can you see one patch is much clearer than the rest? That is where the electrodes are. Don't know if that's a design, that's how it's designed, or if that's just how it's worn. See that bit there is much clearer than the rest. Let's see if we can come away from all of that. Actually, don't look too bad. As you see, that burner looks okay. Okay, so as you can see here, the design of the electrodes has changed considerably. The sight glass has gone. I believe this is the second generation of electrodes. Obviously I'm fitting now the third. I believe the first generation had a much smaller insulation coming off the back of the electrode there. So there we go. Obviously we changed the seal. Okay. Just pop that burner back in. Nice. I'm going to get this in now like other boiler brands. We need to hook them in underneath them tabs at the back there, while missing all of this stuff. So look, spin it round, angle it in. Okay, see how that went in nicely? Drop it down, easy. See, no gap here. The absolute joys of changing 500 litre vessels, look. They don't fit out that way. So this new one has come in, see that the end of that ladder? Coming through that hole there, across all the top of them boilers, through here, to get here, make it up, and they go in here. So we've had to take out the front one to get to the back one to replace it. And this one's full of water. And that one's, the diaphragm's gone, or the bladder's gone in that one there. So I'm going to chop that one up and get it out. This one, we haven't got another one to replace it with just yet. But yeah. And it's attached to 3,500 litre buffer there. 3,500 litre buffer there, so 7,000 litres of water. Only on a Friday. Again, no gap there. Love it when the manufacturer puts this behind the fan, eh? There we go. So, next, take that gas valve out, replace that, get everything back together here, including the sump, and we get it tested. And this is the hard bit now. Once this is changed, which will take us 2 screws and a nut, it's setting it up. It will take time, and you can't shortcut this, otherwise this boiler's going to be back like a boomerang. The new gas valve is in, but you can't get this in without that bit, without the fan and the burner stuff being able to move. So, see that? I've had to lift it all up, and now I can get it on top of that gas valve, and then I can pull it down quite easily. So it'll take 2 hands, but yeah, you have to leave them undone for that, and then obviously do them up afterwards. So when you come to put this trap back in, which obviously I've cleaned out and is now dripping a little bit, you need to make sure you get this pushed through from outside, because once the trap's in, you can't get that in. It's very difficult. So the first thing I'm going to do with this trap, as I slot it in here, I will be holding this from underneath to make sure I can get it all together in one go, because trying to do it as 2 separate pieces is very difficult. Okay, so 2 hands needed for that. Now I'll just get this combined PRV onto that. The way you know if the PRV is leaking is there's a bung here. You just pull that bung out, and if water comes out, the PRV's been leaking. And obviously you can then just pull this tube off here and look at the PRV. Okay, you see that's in. I'm just going to get the screw in from underneath. That's now in place. That's on solidly. It's on there solidly. So I'll just get that screw in the bottom, which is there. And then it's set up time, which is the real work. Sparking. Lit. Okay, so our boiler lights. Now we've got to get this thing commissioned, so we do not let this boiler get hot because this could ruin the whole next bit of this job. We know it runs, we know it lights. So we're now in the process of setting it up. Okay, now I've found the problem really easily. Look, it's right here. Pressurization unit. So that's the fault. That is reading too high. So to get this working, all I have to do is drop some pressure out and I'll get that pump running. But I've been told not to. I've been told not to get this up and running because someone else has got to come and do it. So we have 4 tower blocks down right now because of this simple fault that I'm not allowed to fix. What a joke. Absolute joke. Well, saying that, it's so that we don't step on other contractors' toes. So another contractor has the thing with the pumps. Someone else got the contract for the pumps. Therefore, they're going to come and sort it out, even though this fault is with the P unit. So I don't know. Simple things that you're not allowed to touch. Okay, so I just got permission to actually resolve this issue because I said it was silly that I was here and I wasn't. So I'm just going to get a hose from the van and get it done. Okay, so I'm just going to run through this fault real quick. So let's flip you around. This pump's on stop. This one's running, so this is the heat inside as such. Okay, and all this pump does is take heat from the plate along there and put it into that 4,000 litre buffer over there. This one, we've got an inverter that was faulty, that's not there, and this one's on stop as well. Okay, so they're now both on stop because there is a foot. Originally this one was still running, okay? That's because this is wired wrong. That's because this is wired wrong. So what should have happened is when this pressurization unit, this one here, went to fault, this is obviously on the secondary side, which is these pumps. Okay, that P unit is for these pumps, the ones on the right hand side, which is taking the water away from the plates. Okay, so what should have happened when that tripped over there, it should have knocked off that pump and that pump, because the pressure, there's a problem with the pressure, is too high. It should have knocked off these 2 pumps instead, or all of the pumps. Instead, it's wired wrong, so what it was doing was knocking off that pump there and that pump there. On the front display you could see that originally. Now, because it's been at fault for some time, it's just knocked off everything except this one, which is still running for whatever reason. We don't care about that. We don't care that this one's running. We need this to run, but we need that to run there. So all I'm going to do is drain off some pressure. This might do it itself in a minute. If it cools down enough, it will. I'm going to drain off some pressure to get rid of this fault light from this unit, and that should then bring all of this back up. So how many green lights have we actually got on this now? 1, 2, 3. Okay, 3 green lights. There's my hose and my grips. Let's get this going. Oh, we're back on. We're back on. Look, just as I walked over here, look, they're all coming back on. Yeah, we're back to all green now. The fault on the P unit's gone. See that? So now we're going to have a boiler fire. Once these pumps run for a bit and we get some heat out of it, the boilers will run.
which they are now. Yeah, these are the boilers. So they're now running, which they're over here. Once they get a bit more heat in the system, this is going to go back up. We're at 5.7 bar there. That will go back up and it will create a fault on here. And that will stop the pumps again. We'll wait and prove that that happens. Once we've proved it happens, I'll drain off some water, fix that, this will all work, and these 4 buildings will get some heating and hot water again. Right, just turn the light back on there. I want to show you the buffer temperature. So I fitted gauges to the buffer last week, earlier this week. Not even 60 degrees. Just over 50. And then just over 50. Literally just got my hose set up. And I've walked back in, it's on stop here. Still running, and if we come over here, we'll see that the BMS has shut off plate 2 primary and secondary, when what it's meant to do with this fault, it should be shutting off the secondary pumps on both sides, as far as I'm aware. Okay, it drops out the boilers. No, it doesn't. Boiler's still running, but you can see it's left these 2 running and turn them 2 off. So I'll get rid of this fault now, and I think after a few minutes it turns off both of them, these 2 as well. So we'll get that reset. Are we running? Are we draining? Not yet. I'll turn this off a bit so that we can see that clearly. Okay, there we go, cleared. So I want you to see this as well. That's on stop, yeah? There we go, it's all bouncing around over there. That's starting again. And obviously all I'm doing is draining off the pressure. So all it is the P unit causing all of this, but it does mean that it's wired wrong in the BMS. So all I'm going to do is knock this pressure down. The boilers are running again. 5.2 bar. Knock it down to 4.6. 4. I'll probably knock it down to 4. And with the heat that goes into the system, the expansion of water should take it up a bit more. Obviously that's not great. Got to be careful with this. Anyway, I need 2 hands now. So there we go. Knocking this pressure down. Where are we at? Let's go. We'll go over to the easy one to see. Yeah. I'll knock that down to 4 bar because we've got 4,000 litres of expansion going to take place there, and that is still not at 60, so you know that will take a little while. But now I will obviously keep an eye on it, but I think we're going to find that this is all good. The only thing it does highlight is that we probably need to recharge that vessel. I think this is a 1,000 litre vessel. Sounds good, but I mean, that doesn't tell you much, does it? Yeah, we're here. 4.1 bar. Looking good. Okay, so I'm all tidied up, ready to go. plug back in down there. This hasn't shut off since. So let's have a look here. Right, we're going away from that plate now. 75 degrees. We're already up at 5 bar, I think. Nearly. Well, not quite. Nearly 4.5. No engine start in 20 miles. The van has given me a red warning on the way home to say it's not going to start. Let's see what actually happens. Keys in and neutral. Let's see what happens. Ignition on.